produce steel through this route. Next. Steel through this route contain high phosphorus and sulfur. It is a question today how to solve this problem. As it is this steel also not, it is basically non-treated steel, it is acidic in nature. So therefore, it is not fully formed steel, but still on that finished product like levers, angles, channels, these are produced and it goes to the market, and at the end sometime it lose to the disaster. Next slide. Like collapsing of bridge or building, loss of property and human life. This particular route of steel making is also very popular in countries like Bangladesh, Sri Lanka, Pakistan, Kuwait, Saudi Arabia, Iran and African countries. Next slide. Even in China, this induction furnace also used to produce steel, although that is on scrap route. Their furnace is much bigger size, around 50 ton capacity and 25 megawatt rating. Next slide. The basic reason for following this route of steel making are mainly the low investment cost for the capital equipment, and it has got a very little effect on the power system. Even by own generating power station by the user can use this equipment. Even if it goes in a diesel generator also, this equipment can be run. Next slide. It has got another added advantage that production cost is very low because it is just melted, nothing treated, so cost of production is very low, but at the cost of the quality of the steel. BIS of Indian standard has come to a regulation for controlling this quality about 2 years back, and it is not fully implemented, but gradually it will get implemented. Next one. Now, if this will become very strict, then the problem will come, cost of production to make a quality steel through induction furnace route will become very costly, and as a result, many of the people possibly has to close down the installation. And this closure will be a big problem in the sense that more than 1 million people are working, and it will be a social problem also if these people lose the job. So it became essential to think how this quality can be improved upon. The LD converter by blowing oxygen and adding lime and then subsequently removing the slag, the quality of the steel means phosphorus was removed, and then subsequently this was transferred to ladle furnace where sulfur was removed. Next process was the chemical treatment, and thereafter one more chemical process we will explain afterwards. Next, another experiment was done and already implemented number of places, that is taking the liquid metal from induction furnace and giving as a charge material to arc furnace, and along with that DRI, cold DRI added and remelted, and by that process phosphorus and sulfur was removed. The fourth one which we did, that is having a ladle furnace with a treating arrangement by which we can take out the slag. Now let us describe one by one of the process. Next slide. Liquid steel is taken from the induction furnace to ladle, and thereafter, when it takes to the ladle, it drops down the temperature substantially. To increase the temperature, substantial amount of carbon is added there, and then it is taken to the LD converter where oxygen is blown along with the lime also added, and by this process phosphorus is removed, and thereafter it is taken back to the ladle. Sometimes it can be taken to the ladle furnace for removal of sulfur, and thereafter by increasing the temperature, because there also temperature drop takes place, thereafter increasing the temperature it is taken to the caster. A process flow diagram is shown here. The result of this, we did this experiment in Rati Uddog, Ghaziabad, because they had a converter in AOD and induction furnace, and another one more installation, that is Bharshana Ispat, where they have a induction furnace converter in the AOD as well as this ladle furnace. So we found during number of transfer of liquid metal is taking place, as a result substantial amount of temperature drop is taking place. So we have to add very good amount of carbon as well as oxygen flow. And due to this heavy amount of oxygen flow, lot of steel, that is the finished steel what is coming from induction furnace, is getting converted to Fe2O3, and it is getting oxidized. So there is a huge amount of yield loss. So we calculated in both the cases, we found approximately 15% yield loss takes place. Something goes in the ladle, something gets converted to oxidized, and with that, due to the yield loss, the cost of production becomes very high. See, about 6-7 months or maybe 1 year back, the cost estimation came around 4,000 rupees is coming added cost to purify the steel through this route. Next one experiment was done. See, here what happened, this is basically a process called CSOB, secondary steel making process, similar to that, where we are using a refractory snorkel. It goes inside the liquid metal, and there is a top lens, and there is a chute. Through that and through the porous plate, we are we are parking thoroughly, and through the snorkel we are adding the lime, and on the top of the snorkel there is a place where we are blowing oxygen, because oxygen flow is required here for removal again for phosphorus, and subsequently aluminum is added, because there is a loss of temperature takes place. To generate a exothermic reaction, aluminum is added. In this process, after removal of phosphorus, then after all this process, we have to take out the ladle, ladle car. Ladle car is having a tilting arrangement, and you have to take out the slag. By that you can remove the phosphorus. And then again it is taken back to the same system, same under snorkel, and you add all your ferroalloy, and you can produce the steel. Quality of steel through this route become very good. Next. Yeah, in this process the yield loss is